Thank you for joining us around the world. Welcome to the Global AI Community on Tour. And we are getting ready to speak to Prasanth Pulavarthi. If you have any questions during this session, please feel free to post them in chat.globalai.community. Prasanth leads the product management team for the software stack of Microsoft's AI platform. He is also the co-founder of ONNX, an open standard for machine learning models that is now part of the LF AI Foundation. Prasanth, thank you for joining us. I'll go ahead and let you get started. But would you be able to start off by letting us know what the LF AI Foundation is?
Yeah, sure. Thanks for having me here, by the way. ONNX, which is what we're going to talk about a little bit today, is actually part of the Linux Foundation, which is a open source foundation that hosts a number of other popular projects such as Kubernetes.
Thank you.
All right. So I'm really happy to be here today, talking to you all about solving customers' ML deployment problems. So we all probably know that training machine learning models has its own challenges, but then oftentimes we find that taking those trained machine learning models and deploying them into a production environment is equally challenging, although with a different set of challenges. So I wanted to share some of the problems that our customers, both at Microsoft and externally, have faced, and some of the solutions that we've provided for them. So here's a list of some of the common problems that we see customers having when they try to deploy their machine learning models. One problem is that they train their model, and then when they deploy it, the latency is way too high for the scenario that they need it to run in. Their application may be interacting with the user in real time, so the latency of the model needs to be quite low, but the model is taking too much time to run, for example. Another situation that a lot of our customers run into is their data scientists are Python experts, and thus they do the model training in Python. But then their actual production systems are written in C# or C++ or even Java. So now they either have to rewrite that model that was trained in Python in order to be able to deploy it, or come up with some other kind of creative way to host that model and have it be usable in their production application and services. Another problem that folks encounter is the model needs to be able to run on edge or IoT devices. The training generally happens in the cloud, but then the actual deployment is not in the cloud. And then all of a sudden, you may need to be deploying to devices that, for example, you cannot run a container on. Another issue that comes up is needing to run the same model on different hardware platforms and different operating systems. In many cases, the product that the customer is building is going to get deployed to different configurations, and they may not know ahead of time what's going to be available on those different platforms, or they may know ahead of time that there's going to be different types of hardware available, and they don't want to or don't have their bandwidth to kind of create different builds and different versions of the models for these different environments that they need to deploy it into. Another scenario that we have a number of customers facing is that they are integrating capability for scoring machine learning models into their product, and they need to be able to allow their customers to bring models that have been created in a variety of different machine learning frameworks. And they're not in a position to be able to dictate which framework their customers use. So they need a way to kind of support models that are coming from a number of different formats and places. So these all sound like pretty challenging problems, but help is here. So I'm going to talk to you a little bit about something called ONNX Runtime. It's an open source project. If you follow the URL here, it'll take you to a website. It has a bunch of information there, and then it also links to the GitHub, where you can find all of the source code and information on how to install it. And we'll talk about that a little bit later on. And this is a high-performance runtime for machine learning that's compatible with PyTorch, TensorFlow, Keras, scikit-learn, a bunch of other kind of popular frameworks that create models. So before I talk about kind of the how to use this, I want to give a little bit of flavor of the types of scenarios where this is being used at Microsoft today and the results that they're seeing. So at Microsoft, we offer speech services. These speech services are used in a number of products ranging from Xbox, Bing, Office, Cortana, etc. And they're also available as part of the cognitive services. So ONNX Runtime is being used by this team to power their inferencing. And they use it both in the cloud and kind of on-prem solutions that they have available as well. And they've seen a number of improvements by using ONNX Runtime. They've been able to productize new models faster. And this is because they can take the model and run it through ONNX Runtime, and they get the latency met more easily. They don't have to spend a lot of time converting the model into something else or rewriting the model into something else that can run in the environments that they need to run and at the latency that they need. And because of that, they also see some accuracy improvements. They're able to develop new models faster. This whole thing makes it more agile for them to create models. And it potentially allows them to make bigger models as well, because the latency is lower. So you can kind of create more complex models, but still meet your latency needs. Another service that's benefiting from ONNX Runtime is the OCR service. So this like the name says, it basically helps you identify text content from different images. This is available as an API as part of the cognitive services on Azure. And there's also an option to kind of purchase it as an on-premise product as well. And they switched to using ONNX Runtime for a number of their models in their OCR pipeline. And here again, they're seeing good latency gains. They were able to reduce the latency by more than basically 3.7 times lower. And then they're also seeing higher throughput gains as well. So I talked about two of the different services that are part of the cognitive services, but there are a number of other offerings as well. And these are all using ONNX Runtime. These are all kind of production grade, enterprise grade services that are available, and they're all benefiting from ONNX Runtime. So another kind of component or type of model that is frequently used is transformers. So this is a natural language processing type of model. BERT is a commonly used flavor of this. And these type of models are being used to improve Bing search results and are also used as part of Office. And these transformer models are pretty large, and they're difficult to get to run in a small latency window. So we've implemented a number of optimizations in ONNX Runtime to help reduce this. And this was actually published as a blog a few weeks back. And I'll just give an overview here, and I can share the blog link later on. But basically, with ONNX Runtime, we're able to speed up the inferencing both on CPU and on GPU by a sizable amount. And you can see the numbers here. Basically, the throughput, without optimizations for this flavor of this model is 6, and then once we've optimized it with ONNX Runtime, it jumps up to more than 100. And similarly on GPU, we see strong gains there. And then when you pair the software optimization in ONNX Runtime with hardware optimizations as well, you get even more acceleration. ONNX Runtime is also used in other Office scenarios. There's a grammar checker in Word that you probably used. There's something called a missing determiner as part of that that checks for this part of the phrase that's missing. And this team also saw almost more than 14x performance gain by switching to ONNX for their production solution. And then by using the quantization features in ONNX Runtime, they're able to reduce the memory footprint of the model itself by half. Another feature in Bing is the visual search. You basically can identify, you can provide a picture, and then it'll identify what it is. You know, if it's a flower, you know, what kind of a flower it is, for example. And here again, they're seeing good performance gains. They're using GPU in this case. So here the hardware is not a CPU; it's a GPU. And they get performance gains from using Onyx Runtime with the built-in GPU support. And then one of the things we're going to talk about is that Onyx Runtime is actually extensible. So they're actually partnering with NVIDIA to use TensorRT as part of Onyx Runtime, and they get further gains by doing that. And we'll talk about this a little bit more later on, but this extensibility allows you to plug in the latest hardware accelerators and the related software from a variety of different vendors into Onyx Runtime. So you can always get, you can kind of compare your choices and see which one gives you the best performance without having to change the API that your application is coded to. So if you didn't have Onyx Runtime in the picture, you would basically be using 2 or 3 different types of accelerators here, and then you would have to change your application to interface with each of those, or write your own abstraction layer to kind of interface with them, and then modify how the inputs work and how the outputs work and all of that. So this simplifies the development process of finding the best configuration. Another example is Azure Connect development kit. This uses the kind of the depth sensing cameras that are part of the Azure Connect device to allow you to track bodies in 3D. And here again, they saw good latency reduction. And here the interesting part is one of the scenarios is to run this application on your desktop PC. But another scenario is actually run it on a small IoT device. Now here they're able to use the same model and the same Onyx Runtime on both of these classes of devices, both the desktop as well as this very small board that's basically an IoT computer. So this ability to run the same model and the application code across different platforms is pretty useful for a number of reasons. It allows you to kind of create your model and your application independent of what hardware it's going to get deployed on, and then at the deployment time you can just put in a different execution interface or execution plugin for them. So here, these are examples of there's a Python script that's calling into Onyx Runtime, which calls the same Onyx model, and the only difference is that they're running on 3 different devices. It's a Surface PC that runs Windows. It's this Upsquare device that runs Linux and has a VPU in it, and then this Jetson type device that runs Linux and has a GPU in it. And it's the exact same code, but it's able to run on these different platforms, and they get different performance, because depending on the hardware, the underlying hardware that's available, you'll see that the same program is running on all these, but they finish at different times because of the underlying hardware differences. But from the application programming interface, it's all the same, and you also get the best performance you can on each of these devices without having to spend a lot of effort trying to tweak it for each of the different devices. One last example, Windows ML. So you may have heard of this. It's part of it's one of the Windows APIs, and it facilitates machine learning inference. It makes use of the DirectML acceleration, which is kind of part of the DirectX family. And because it's part of the Windows API, it's very easy for developers of Windows applications to use. And because it leverages the DirectX infrastructure, it has broad hardware support. And this API is basically built on top of Onyx Runtime. And so this is an example where Windows wants to be able to allow people to run models from a variety of different frameworks. And this allows them to do that and provide kind of a common API regardless of where the model came from, which framework the developer created the model in. So to kind of summarize the Onyx Runtime usage at Microsoft, There are a number of teams using it. Onyx Runtime is installed on millions of devices. It's handling billions of requests in production environments. And we're seeing more than 2x, 2.9x average performance gains by the services that are using it. So in addition to Microsoft itself, there are also other Azure customers who use Onyx Runtime. For example, there's a financial ISV who's using Azure and Onyx Runtime on Azure, and they basically use AI to model different economic scenarios for their clients. And they train their models in Python with scikit-learn, but then their production environment is all C#. So here they're using Onyx Runtime so that they don't have to kind of replicate that model, rewrite that model in C# from Python. They can just use an Onyx Runtime C# API and plug it into their environment. And in their case, they also happen to get a 2x speedup. That wasn't their goal. Like, they were happy with whatever latency, but they get that for free. Another example is an e-commerce platform for the travel industry. And they use AI for pricing experiments. So their customers can bring their own ML models and try out how to adjust the pricing and what that'll do to sales and such. And here, Onyx Runtime, its flexibility of taking in models from different frameworks allows them to bring in new customers. Before, they only could allow a specific framework, models that are created in a specific framework to be used in their system. Now they can tell their customers, hey, you can write it in whatever you want and come to us, and we can run that model and plug it into the rest of our platform. So it simplifies their engineering. They don't have to maintain all of these different runtimes or ways to inference their models. And it also improves the customer experience because they're not restricted to a specific framework. So hopefully that sounds good. We have a lot of success stories there. So how can you get started? How can you actually start leveraging this functionality in your applications and your services or with your customers? So a couple of things I want to talk about. The first is pre-trained models. So many people will have their own models and they won't want to use them with Onyx Runtime. However, to get started, you may want to use a pre-trained model, or you may want to use that as a way to test the system or just get started. Or in some cases, the pre-trained model is actually good enough for what you're trying to do. So there's a large set of pre-trained models in the model repository, the model zoo, at this URL, onyx.ai/models. It'll take you to a GitHub site that has a number of different categories of models. You'll see vision models, language models, and several other things. And you can drill down into that, and you'll see kind of the types of models that are available. They're fairly, it's a fairly comprehensive set of vision models and language models, we think. There are more being added, both by Microsoft folks as well as the community. You'll see some of the latest models there, YOLO v3, Mask RCNN, etc. And when you click through to that, you'll have a Jupyter notebook that shows how to use the model with Onyx Runtime, and kind of what kind of data it needs to pass in and what to do with the output once you run the model. So if you don't want to use a pre-trained model, you already have your own model and you want to convert it into an Onyx model so that you can run it with Onyx Runtime, well, you have a couple of choices. So these are all the different frameworks that support Onyx models. So you probably see the one you're using on here. And I wanted to share a couple of examples of how you would do that for a few kind of popular frameworks. By the way, all of these are the documentation and the tutorials for how to do this are available in the GitHub repositories, and we'll have some links at the end so that you can go check out the notebooks and try it out for yourself. So PyTorch is one of the popular frameworks, and it has a really nice way of being able to use Onyx Runtime. There's Onyx support is actually built into PyTorch. As shown in the code here, you can basically load the model and then export it into Onyx format. If you're familiar with PyTorch, you know that it has something called torch script as well. And the ONNX export works with torch script. You can either do a tracing method where you kind of walk through the graph, or you can do the torch script export method as well. And both allow you to save the model as an ONNX file and then run it with ONNX Runtime. We've had a number of customers who've had trouble kind of figuring out, how do I operationalize my PyTorch model? PyTorch is, they love it because of the convenience and the agility that it provides to create models. And then they were trying to figure out, how do I actually take this to production and deploy it in my production service or in my application client application. And so ONNX Runtime has enabled them to do that. So as I mentioned, this functionality is built into PyTorch, and it's documented as part of the PyTorch documentation. If you're using Keras, either the standalone Keras or the Keras as part of TensorFlow 2.0, then you can use the Keras converter. This basically allows you to take a Keras model, convert it, and then save it out. Again, the API to do this is fairly simple. This supports multiple versions of the Keras APIs, the latest version also works with TensorFlow 2.0. Of course, if you're using TensorFlow itself, either 1.0 or 1.x or 2.0, there's a TensorFlow converter as well. You can take your model, and it actually accepts multiple formats. There's a frozen model, there's a saved model format, so it can take a number of those different formats, it's pretty flexible. You can tell it a number of different ways to optimize the model that you're exporting, and then you can save out your ONNX file. The good thing about ONNX Runtime is that it supports not only DNN, but also traditional ML. So if you're using something like scikit-learn, which is very popular, you can use the scikit-learn to ONNX converter to basically convert your scikit-learn model, your scikit-learn pipeline, into an ONNX model that you can then run. And this allows you to kind of avoid the issue of saving your scikit-learn pipeline as a pickle file and then trying to load that up somewhere else. And dealing with the versioning issues with pickle, or the fact that you may not be able to have a Python environment on your devices or as part of your application. So this is a way to go from kind of a Python world into a C, C# or Java world. So once you have your model, some people like to visualize it. They want to see, okay, what did this converter do? How did it change the graph of my model? So you can do that. There's a tool we like called Netron. The link is here. Once you install that application, you can load up the ONNX model and see all the nodes in the graph, and it integrates with the ONNX documentation, so you can actually click on each node and kind of see what is that operator doing and what are the inputs and outputs. All right, so now you have your ONNX model, and it's time to use ONNX Runtime. So let's talk a little bit about the different places that ONNX Runtime works. So when you go to the ONNX Runtime website, you actually see this kind of picker that shows you the different places and ways that you can run ONNX Runtime. So it runs on Windows and Linux and Mac, and also there's a preview version of it working on Android. It works with Python, C++, C#, C, and most recently Java has been added by the community as well. And it works on the CPU architectures of the ones that are mentioned here, x64, x86. It also works on ARM, so you can run it on the smaller devices. And then it supports a number of different hardware acceleration. And we're going to talk about this a little bit more, but basically you can pick or you can run ONNX Runtime on a variety of different accelerators and get the most benefit out of them. And we're going to talk about that a little bit more. So when you actually have ONNX Runtime, here I wanted to show you what the API looks like. So I'm showing both a Python API and a C# API. So at the highest level, it's super simple. You import the ONNX Runtime library, you create an inference session using the model, and then you run the model by passing in some data. And then you get the results, the outputs in the results. And that's about it. The API also has some other functionality to allow you to tune different settings and customize how memory is allocated and what hardware to use and things like that. But pretty much those are all kind of optional, and these are the core methods that you would use to run it. And if you go to the tutorials website on ONNX Runtime GitHub repo, you'll see more examples of how to use this with real models. And these APIs are also available. I'm showing the Python and C# here, but they're also available in C, C++, and Java. So here's kind of a really high-level architecture of ONNX Runtime. Basically, the ONNX model is one of the inputs. It optimizes the model as much as it can. It partitions the model so that it figures out like how much of it needs to run on the CPU and how much of it can run on the accelerator that might be available. And then there's model optimization that happens for that specific acceleration device, and then it runs it. And then you get the inference results. So these execution providers are listed here. So there's a default CPU accelerator or execution provider here that is optimized for running on CPUs. So even out of the box, you get really good performance on CPU. However, if you want to run with other accelerators, you have that option as well. So ONNX Runtime comes with CUDA implementation so that you can run on NVIDIA GPUs. And we also partner with NVIDIA to integrate TensorRT. So if you have, if you're using an NVIDIA GPU and you want to try out the TensorRT, maybe TensorRT has been optimized to run the type of models that you're trying to run, you can do that with ONNX Runtime. Another advantage with doing that is that you may have an ONNX model, your model, a part of it may run via TensorRT, but TensorRT may not support all of the operators that your model uses. So if you use TensorRT by itself, your model just won't run. But if you use it with ONNX Runtime, then it'll still run. And all the parts of it, all the parts of the model that can be accelerated get offloaded to TensorRT and the GPU, and they run there. And the other parts that cannot be supported in that path get run on CPU. So you still get a fully functional experience, and you get as much optimization as you can, given the model that you're working with. DirectML, which I mentioned as part of Windows ML, is also available as or is implemented as an execution provider. So you can actually use ONNX Runtime with DirectML on any kind of version of Windows that supports that. We also partner with a number of other hardware vendors. Intel is one of them. OpenVINO is very popular. A number of people use VPUs for vision models in particular, and OpenVINO has been optimized for those. And here again, by integrating with ONNX Runtime, Intel is allowing their customers to run a broader set of models on those VPUs. If you only use OpenVINO, then only the models that are fully supported by OpenVINO can run. If you use ONNX Runtime with OpenVINO, then any ONNX model will run, and as much as possible will eventually get accelerated on the OpenVINO powered device, the VPU. We also have a model compiler that's primarily optimized for RNN type models. That's called NUFAR, and it's available in the repository as well. As I mentioned, Android is currently in preview, and we have an API integration there. If you're building a mobile app and you want to try this out, please do so and give us feedback. We're really interested in seeing how you find it. And then there's also an ARM compute library execution provider that's available for accelerating models on ARM chips. So ONNX Runtime tries to provide the best settings out of the box. So if you just download it and you run your model, you should get very good results. But a lot of things vary with machine learning, right? There's your model, the complexity of the model, the types of operators you're using, the type of hardware you're running on, whether there's an accelerator or not, whether there are other processes running on the device, etc. So there are a lot of knobs that we expose if you want to tune the performance further for ONNX Runtime. So we have an optimizer that's built in. By default, it runs at the highest level possible, but you can always adjust that if you need to. There's also quantization capabilities that you can use to either reduce the size of your model or accelerate the performance of the model. There are the different execution providers that we talked about. Some of the execution providers have additional settings in terms of number of threads and kind of the behavior of how to run things. And then the executor, in terms of how we execute the model, also has some settings in terms of how many things we should do in parallel, how many things we should not do in parallel. So there are a lot of knobs available, but this diagram looks pretty complicated, and you may find that it's a lot of work to try to tweak all these knobs. So what can we do to make it simpler? Well, we put together a pipeline that helps you do that as well. So there's this thing called ONNX Go Live, or Olive for short. It's available at this GitHub location that's linked here. And it basically automates the process of converting your model, verifying that the results are still correct, and then tuning the performance for your deployment environment. And if you go to that repository, you'll see that it's basically implemented as a set of container images. And so you can run through, and there are tutorials there as well, and you can run through that and convert models from a number of different frameworks and tune it for the hardware that you're trying to run on. And we use this for tuning the models that we talked about earlier that our customers are using, and we encourage you to try it out as well. We're also seeing how to integrate this more into Azure ML, so that if you're an Azure ML customer, you can get a better experience of using this. Of course, anyone can use this right now, and we encourage you to do so. All right. Well, I wanted to provide you some resources before opening it up to questions. There's the website for ONNX Runtime is linked here, as well as information about Windows ML, which would be useful if you're a Windows application developer. There are also a number of tutorials that are available both on the ONNX Runtime GitHub as well as the ONNX GitHub. And these tutorials also have information about how to use the different converters that we talked about to go from PyTorch to ONNX, TensorFlow to ONNX, scikit-learn to ONNX, etc. If you're using Azure ML, there's information at the link that's provided on this page about how to use ONNX Runtime to deploy to IoT edge devices. There's information about the different container images you can get from the registry and how to deploy those. And then there's some tools that make it easy for you to get started. There's, of course, the Olive performance tuning tool. There's also an ONNX ecosystem Docker image that has pretty much all the tools you need installed in it. So you can just download and run that container, and you have everything ready to go. All right. Thank you.
Well, that was great. There's a little bit of an echo. Is that better? So thank you, Prasanth. So we had a couple of questions. So what are some of the coolest projects that you've seen on ONNX?
One cool project I recently heard about is someone is actually using ONNX Runtime as part of a genomics pipeline. They're analyzing like protein. I don't know the details that well, but they're basically analyzing these different genomic aspects, and they have some machine learning models that run on that data. And in order to be able to accelerate that inferencing and kind of facilitate running these models, they're actually using Onyx Runtime. So that was a cool scenario where Onyx Runtime is being used. And I can point you to the GitHub repo of that researcher if you're interested. I'm not doing justice in explaining their the genomics part of their application.
And we've noticed that there's a lot of integration with ONNX and Microsoft tools. Can you speak to anything that's coming up in the future as far as integrations with the software?
Yeah, I mean, there are a number of teams already using Onyx Runtime at Microsoft, and there are more coming up. In terms of Onyx Runtime itself, we just we release every few months, so there's a upcoming release, and you can actually track the progress of it on GitHub. You'll see that there's a lot of improvements in the latest master branch, and those will all be packaged up and shipped as a upcoming release of Onyx Runtime. If you're interested in Onyx itself, there's actually if you go to onyx.ai, you'll see that there's a Onyx community workshop this Thursday, actually. So the Onyx community puts on this quarterly meetup, and different companies who are using Onyx come and talk about what they're doing. And so if you're interested, you can join it's this Thursday.
Fantastic, thank you. And we did have a question about, and I did hear you mention some of these, but I think maybe they were asking for a little bit more detail. There was a question from a viewer, can the pre-trained models be tweaked or customized to fit the specific needs?
The pre-trained models are in Onyx format. So it depends on how you want to tweak or customize them. If you want to kind of train them all over again, then currently you cannot do that. You would need to kind of go to the source training framework and do that for now. If you are, some people will take those models and do some quantization on it, for example, and that's, there's tools available to do that. And so it depends on the type of customization you want to do. Some people also use those models as part of another pipeline. So you can kind of use one of the pre-trained models as a featureizer that then leads into another step in your pipeline. So some people have done something like that as well.
Okay, great. And Sami has over to Sami for a quick question. So his question was, Onyx is a collaboration between different big firms other than Microsoft. So how is that collaboration going?
Yeah, so the Onyx format is an open standard, and it's a collaboration with a number of different companies, Facebook, IBM, Intel, NVIDIA, et cetera. If you go to the ONNX.ai website, you'll see all the participants there. And if you look on GitHub, you'll see that as well. So I think we're part of the Linux Foundation, as was mentioned earlier, and so there's an open governance process in place, and which defines the steering committee, which has people from 5 different companies on it. There are different SIGs and working groups that are led by folks from different companies, and there's a process for how decisions are made. So overall, I think it's going well. We see new people joining the community regularly, and if you tune into the Onyx Community Workshop, you'll see the different things that different people are doing with Onyx. Now, Onyx Runtime is Microsoft's runtime. It's all open source, but it's primarily worked on by Microsoft folks. But we've also started having community contributions from other companies as well. And if you look in GitHub, you can kind of figured that out. But we see a lot of great contributions coming in from non-Microsoft people as well.
Okay, well, so last question. We would like to know if you do have a Twitter handle.
I do not.
Okay, I'm sure you're working on that though, right? So, in the interim, if anybody has any questions, they can feel free to enter that into chat.globalai.community. And we do have a couple more minutes left. So if you did have a question, I'm sure we have at least a couple more minutes to go over some material. If not, we'll go ahead and share those with you, Prasanth. And thank you for preparing this session. It was great material, and we're
maybe I can
happy to have you.
One more question, Prasanth.
Yeah.
What's the last big change that you really noticed that you were like really surprised of in the AI world?
I mean, there's so many developments happening. It's hard to kind of pick one. Kind of one trend that I've kind of heard about lately is models are getting so large that we might have to do distributed inferencing as well. So models are training. We've all kind of accept that, hey, for training these models, we need multiple machines, multiple GPUs, et cetera. But even for inferencing, we may need to do that for certain types of large models. So I think that's an interesting development, and will change how some of the accelerators are engineered and how they work together, and also how the software stack on top of it needs to work.
What are your thoughts on more publicly available domains and data sets? And so I use custom vision, and you can go ahead and configure against specific domains. And do you see more maybe proprietary domains being available, or domains in the marketplace maybe? And like we have data aggregators, right? And we talk about monetizing data. So is that something that we're going to see in the future?
So unfortunately, I'm not the best person to talk about data for ML. My focus is primarily on kind of the inferencing and training of models, and data is not my domain currently.
Okay, no problem. Well, maybe also another one. Well, we see that Onyx has been integrated in quite some Azure services where you can just download the Onyx file, for example, in certain cognitive services. Any insights of new developments that are coming?
So in terms of specific new functionality that's coming from the cognitive services, I would defer to the cognitive services folks to answer that. I think there are some sessions on that.
More integrations with Onyx, like other services that will easily have the implementations with Onyx files.
So yeah, I'm not sure I have any new information to share about that. They are, as you know, Custom Vision already supports it, and a number of other services use ONNX Runtime as well. So if you have any specific feature requests, I'd love to hear that as well, because that helps us prioritize and kind of work with different teams to get that functionality made available.
All right. So anyone who's watching, if you have any feature requests, shoot out to Prasanth, and you'll see what he can do.
I don't know. He won't give us his Twitter handle. No, I'm just joking.
No problem.
I'll monitor the chat channel.
All right, that's perfect. Okay, then we'll keep it for that. We'll have another break now. It's going to be a little bit longer. In the meantime, Alicia is leaving us, but she'll be coming back later, and we'll have another host who will join us in a bit. Thank you. See you in a bit.
Bye, guys.
All right.
Hey, my name's Akanksha Malik and I'm from Melbourne.
Excellent Somi, it's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasanth from California.
大家好，我是卢建辉。
Ik ben Willem uit Nederland.
I'm